Well, hey guys, welcome back to Detroit Garage. Well, now that we've got the flywheel finished for little Jimmy, I can concentrate on the hydraulic pump. I did mention in a previous video that I'd be switching out this pump, but I've decided to use the existing pump that was on the Buda. It's not the ideal pump, but it works, and I'll just have to take it easy on that one. So it should have been a simple process, but nothing simple when you have to adapt things. So here's the Deere 440 adapter, and that ran a geared 1-inch 6-spline shaft, and that's what was on the Deere, like that. But I turned out the center of this piece to press in the center of this. I cut this out. It's on the lathe right now. I cut this out and then I pressed it in here. When I turned this out, I was thinking, wow, that's really hard steel. Maybe I should test that before I go any further. But I thought, nah, I'll be able to drill through that. So the plan was to press this, the adapter for the pump into here with a 4/1000 fit, and then drill 2 holes, 1, 2, and put my set screws in there. And the tiny little 1/4-inch set screws are there, and that'll lock it into place. It'll never move. So I did that. But when I went to drill this, I could not touch it. The drill bits just didn't even, nothing. Take the paint off and that's it. So very, very hard steel. I knew that when I was cutting it on the lathe, and I thought I better check this, but I didn't. Anyway, I reckon it's about probably 4140 hardened. And the reason it was hardened is because it had to run that shaft. The shaft, I don't know where I put that, but there's a hardened steel shaft that went into there, and wow. So I had 2 choices. One, anneal this piece, heat it up cherry red, and then anneal it, or cut it off, bore it out, and put some mild steel in it. So that's what I did now. I put mild steel in it. What should have been a simple job has turned into a couple of hours, more than a couple of hours. I've been working at this probably 3 or 4 hours now. So I welded it, I bored it, I pressed this in with about a 2/1000, 3/1000 interference, pressed it in with the lathe, or the press rather, turned it on the lathe, welded it and turned it on the lathe, and now I'm gonna bore it out and fit that other adapter back in. I'll go get the adapter and I'll show you what I'm talking about. So here's the adapter. Where is it? Okay, it's this centerpiece cut out and then pressed into, here like that. And then there's going to be 2 set screws to lock it into place, 1/4-inch set screws, and that would have been perfect. But it didn't go. According to plan. So I thought I'd bring you along for some of the lathe work, and then the pump work. We're going to set the pump and then make the. I've got 1-inch bar. We're going to make the mounts for the pump out of this. Drill and tap those for the pump side, and then weld the engine side onto the engine mount. So that's my solution to working around this Italian pump and the Deere 440 hub. So. Okay, so I made a safety step in here, this little one here. And what I'm going to do now is I'm going to press this in. So use red Loctite, press that in. It's about a 4/1000 interference or so. And then 2 set screws, one on each side, and that's not going anywhere. With any luck, I don't wreck this piece. Okay. I don't think there, that's as far as it goes. That's 5 tons of pressure, so that should work pretty sweet. And it's nice and snug, of course. When you press it down, the aluminum shrinks. But it is, it goes on and off the shaft. What I'll do next is I will drill and tap two holes through this to put the set screws in. So that's what I'll do next. Well, several hours later, I'm back to drilling and tapping these set screws. So I've drilled the hole. Now I'm going to tap it and put the set screw in. And then we'll lock it in with blue Loctite, and it won't go anywhere. So this is not a permanent solution, but it'll get me by till I find some setups that bolt right on here. I've run not into a roadblock, but I just haven't found the ideal pump or drive system for it. So this is basically my temporary solution to my pump problem. There. That's a nice, turned out really nice. All right, well, here's the one set screw. I still got to go buy another set screw. But that's it. I guess one could tighten the shaft down with that as well. But I'm just going to set it into the aluminum, and that should lock this in if it would ever turn. It's got red Loctite in it, so I don't think that's going anywhere, guys. So I'll reassemble this with the rubber bits. All these new rubbers go in here. And then the next plan of attack. So this is the thing I don't like about this pump. And that's why I want to upgrade it to something different with this style hub and a larger shaft, because it's a 2-piece pump. As long as that shaft's in there, it's fine, but it's really just a worm, not a worm gear, but it's off-centered, runs a gear in here, and it's prone to breaking. I'd like to have a pump like the old one that went right through, the shaft went right through the unit, not driving another gear. So It's you can see if you pull that out at all, there's a lot of a lot of movement. It has to be pressed in there and then it's fine. So that's the pump. And now we're ready to put it on, and I have to make the brackets with that cold rolled steel here, or hot rolled, I guess this is. I guess that's hot rolled, but 1-inch bar. We're going to make mounting plates for it. So there it is with the hub bolted. Well, there you have it, guys. That's the hub built to run the pump. And the next step is to mount this to the Detroit. So I'll bring you along for that in a separate video. And we'll make a bracket for this thing. Well, there you have it, guys. That's the hub finished to drive this pump on the Detroit. And the next step in this is to mount the pump. So I'll bring you along for that in the next video. So again, thanks for checking in, and we'll catch you on the next one. Take care.